All right, so here's some examples using the Pythagorean identity. And they're going to be sort of algebra heavy because, at this point, the assumption is you've done the problems that lead up to this. Okay, so the one idea, and if you have not, make sure you go back and look at them because I've built the problems to this point based on the idea that we've reviewed some algebra. So identities, again, this is your answer. This is not something you're trying to move over to the other side or solve for at this point. That may be possible later, but right now that's what you're trying to get for your answer. So the first thing we're going to do is we're going to change, not this, again, if you get sine and cosine, those or tangent, those just sort of stay the same and you change everything else to kind of reflect them. So secant is the reciprocal of cosine. So we're going to change that to 1 over cosine. And then once we do this, we're going to try to find a common denominator, very similar to the problem I did earlier. So if you're asking why is it doing denominators, you might want to go back and look at the rational problem I did earlier. Okay, so what I'm going to do is this has a 1. So, I mean, you can multiply by 1, it doesn't do anything. And this has a cosine. So we would multiply this by cosine. Okay, and then I would have my common denominator, which is just cosine. Okay, so cosine goes here and here. Okay, but on the top here, we now have cosine cosine, which would be cosine squared theta, not cosine squared theta squared. The square goes on the cosine and not the variable. So make sure you're squaring the right piece. And the other piece here would just be 1, right? And so then we would put this together and we would get cosine theta on the bottom, and then we get cosine squared theta minus 1. Basically, when you see Pythagorean identities, you need to be looking for squares with ones. That's really the kind of the clue in that you're using these identities. However, this is actually backwards. If you go back and look at the identity list says that it should be 1 minus cosine, and we have cosine minus 1. And the easy way to explain that is that this is in fact sine squared like you think it is. So it is in fact sine squared on the top, just like you think it should be right here. However, it is backwards, so you have to put a minus on it. And I'm going to show you the algebra behind that in a second. But when I do my own assessments, I just say, okay, Pythagorean identity backwards is the identity with a negative, because in math, backwardsness means minus. So let me just take a little wander into why for my students who want to know why. The reason is if you were to write it the correct way, it would look like this. Okay, so 1 minus 1, minus 1 and minus 1, there's a positive right here. And then you can't have negative lead coefficients, so you would divide by a negative. And that would give you 1, but then that would change to a minus. And then that minus on the front would stay. And then this part would transfer into sine squared from the formula. And then we would go back to there. I think it's a whole lot easier to just listen to me and say, hey, that's backwards, the thing, so it's negative. All right, so we're not done yet. That's not the answer it told me to get, but we're almost there. So how do we get to the answer? Well, another thing in trig that's really important is to understand that, so going back to algebra, x times x is x squared, right? So that means that sine squared is really sine times sine. And of course, we just saw that a second ago when we did cosine cosine, right? So we're actually ripping it into pieces. And then this cosine would stay down right here. Well, this thing, sine over cosine, is tangent. Hey, that's what they want me to get. So then I would get my final answer of negative tangent theta and this extra little sine theta sitting here. And that is, again, what they wanted me to get in the original problem. So I'm done. Please keep in mind that the majority of the work is what's graded for this. So these steps are graded. This is very few points because we're telling you the answer. So just keep that in mind. But it is nice to know where you're going. There's another thing called simplifying trig expressions where we don't tell you the answer. That's a different lesson, but it's the same idea. All right, so take a look at this one. And this one, we're trying to get to cotangent squared. Okay, so to get cotangent squared, what you're going to do is you're going to follow the algebra. Well, the algebra says I need to multiply, right? So if I had, so to show you the algebra behind this, if I had x times x minus y, notice I used x for cosecant and this for sine, I would get x squared minus, oh, just alphabetize that, xy. So the same thing is happening here. This would be cosecant squared, and this would be sine times cosecant. Now keep in mind, when you make this cosecant squared x, you don't square the x. You only square the function, not the variable. I mean, if you really want to think about it, it's because it's actually in a parentheses. It's inside of cosine or cosecant. Okay, and this would be, now we would not alphabetize this because in trig, the most important functions are sine, cosine, and tangent. So typically we would put sine first and then cosecant, because again, one of the best ways to do trigonometric identities is to make everything sine and cosine and see what happens. All right, so looking at this, cosecant squared is good. We want that. That's part of our identity. Like if you look over here, cosecant squared, it's in multiple identities. So that's good news. So when I look at this one, the question is, okay, what's going on with this? If this is good, what is happening here? Well, let's see. The sign is not going to change. However, the cosecant, if you go back to the original identities, that is the reciprocal of sine. So that's 1 over sine. And then these two things would cancel because we're multiplying, not adding. We don't have to find a common. This we had to find a common denominator because we're adding or subtracting. This does not need a common denominator because we are multiplying, so we can just cancel. And that would leave us with negative and then 1. And this would just drop down. And lo and behold, this problem, I just get an identity. This is an identity straight up. So I can just immediately say, if I go back here, here's my identity. So I can just, right, cosecant squared minus 1, cosecant squared minus 1. I can just write down the answer, which is cotangent, which is, in fact, what they wanted me to get. So that's awesome. All right, thanks. There's 2 more examples coming.